We have to find the equation of a hyperbola in the first case when the vertices are given and the asymptotes are given. So for this part A, we're going to be using this graph just as a side work, but we're going to have to do some algebraic work to find the actual equation of a hyperbola. So first what I want to show you is that the vertices are 0 plus minus 12, right? So we're talking about actually these 2 points, right? The farthest we can go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So we're talking about this point and 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So this point. So we're talking about these two being the vertices of a hyperbola, and the asymptotes are given by these two lines, right? So plus minus 3x. So plus 3x, and they will have y-intercept, of course, at the origin. We know that. So we can put this point. And notice that this origin point will be common for both plus minus, for the two straight lines being described that serve as asymptotes. So 3x means we're going to have a slope of 1 for every increase of x, right? So for every increase of x, we're going to have an increase by 3 for the y, right? So go 1 to the right, go 3 up. Go 1 to the right, go 3 up. You can see where this is going. This is the asymptotic line. So here go left 1, go down 3. And in the same fashion, these lines, right? So we can connect this asymptotic line using the points that we've drawn, right? So that's one asymptotic line. And the second one will, of course, be using -1 for the -3 for the slope, right? So we're talking about 3 down and 1 to the right, 3 down and 1 to the right, etc. Right? So I'm not gonna spend too much time here. I'm just gonna see where this is going. So I'm gonna start here, and I'm gonna be very careful into how I label these. So we're gonna go all the way up here, right? So these are the asymptotes. And as you know, the hyperbola, the bottom part of it here is going to be the greatest point, right? So it's going to fold down, it's going to open down basically, right, on this side, below the x-axis, right? So we know it's going to look something like this, right? And we know that the hyperbola approaches the asymptotic lines as we go down and down, and for the same thing as we go up and up, it will approach the asymptotic lines if we were to extend them like that, right? So this is what the hyperbola looks like, and as you can see, the focal axis will be on the y-axis, okay? And we know that's true whenever we have the equation of this type, y minus k squared over a squared minus x minus h squared over b squared is equal to 1, right? So we know that. And of course, we're going to be testing when we actually get the equation, we're going to be testing for the correct vertices just in case, to be sure, right? This is not about memory. This is actually about verifying whether you memorized it correctly, right? Because you can always verify mathematically. That's the beauty of it. You can always verify using the given points to see if the coordinates that you're given are still holding true, right? So, okay, so now that we have this equation, we know that the center, of course, is going to be where the asymptotic lines meet, okay? And to verify that, just understand that we're talking about the same x value. Okay, to verify that, you realize that you have to find the center is going to be right between the vertices, right? It's going to be the midpoint of the vertices, okay, of the line segment joining the vertices, right? So the midpoint is going to be 0, 0. How to verify that? Well, the midpoint formula is 0. Well, not 0. It's going to be, let me see. Yeah, so the x value of 0 for both of these vertices, right? So let me label them again so you see them. These are the vertices. So the x value is 0 for both, right? So 0 plus 0 over 2. And the y value is 12 plus negative 12, right? That's the y value for the second one here, for the second vertex, right? So plus minus is essentially minus 12, divided by 2. Right? So we're talking about center at 0, that's 0, and then this is also 0. You see, so we just verified that the center is indeed 0, 0, even without the graph. Okay, so the center is 0, 0. So already the k and h, notice that we're talking about h comma k, right? So this is the h and this is the k. So already, if the k and h are 0, we're just going to have y squared over a squared minus x squared over b squared. All right, so we got that part straightened out. Now let's talk about how to find the values of a and b. So notice that for this reason, we're given the asymptotes. Okay? So in this case, whenever we have the focal axis on the y-axis or parallel to the y-axis, we know that the asymptotes will hold for the following equation. Y minus k is equal to plus minus a over b times x minus h. Okay, we know that. All right. Now it's a over plus minus a over b and not b over a. B over a will be only when the focal axis is parallel to or on the x-axis. In this case, it's parallel to or on the y-axis, so it's going to be plus minus a over b, not b over a. Right? So a over b. So now let's match. Let's match this equation that tells you that represents the asymptotes with the given equation for the asymptotes, right? The theoretical equation versus the actual equation. So let's match what we know. We already said that the h and k are 0, right? So these two are gone. We can cross them out. They're both 0. So as a result, this is equal to what? Y is equal to plus minus a divided by b x. Okay? So now we also know one information. We know that a is equal to 2. Now how did I get that? Oh, sorry, not 2, 12. How did I get that a is equal to 12? Well, I know that the a is going to be exactly 1/2 the distance between the vertices, right? So the distance between the vertices is exactly 24, right? Because this distance, absolute distance, is 12 to the origin, and from the origin on to the top vertex is going to be 12, another 12, right? So 12 plus 12 divided by 2 is 12, right? So I can show it to you. 12, the actual distance from one vertex to the center, plus another 12, the distance from this center to the top vertex, divided by 2 gives us the average, or the value of the a, right? So that's going to be precisely 12. So a is equal to 12. That's good news. If a is equal to 12 and we know y is going to be equal to, we can match what we know, right? So we're going to plug this in as 12, okay, divided by b. So I don't really need the plus minus actually, so I'm going to erase that. As you can see, the plus minus is shared in the theoretical versus the actual, right? So we don't have to write it down. So 12 over b, we're just matching a over b with the 3 there, right? So 12 over b is equal to 3. So what does that tell you? If 12 over b is equal to 3, you can solve for b, multiply both sides by b, okay? And then just divide by 3, and then b will be equal to 4, right? So solve this for b, b should be equal to 4. Another way to visualize this is this. 12 over b is equal to 3. So if you switch them around, you'll be fine. You can switch them around. So 12 over 3 is equal to b. 12 over 3 is exactly 4, right? So the b value is 4. So now we're ready to find the equation, right? Because we found all the parts necessary. So now y squared, now why y squared? Because k, remember k is 0, so we can disregard it. K is 0. So y squared as a result, because y minus 0 is still y. Y squared over a squared. A value is 12, right? So a squared is 144 minus x, and again h is 0, so x minus h is x minus 0 is still x, right? So x squared, right? We don't need the minus h, divided by b squared. B was 4, so 4 squared is 16 is equal to 1. Bingo. We found the equation of this hyperbola successfully using the vertices and the asymptotes. Now in the second part, it's different pieces of information. We were given Foci coordinates, and we're given eccentricity, right? So it's going to be slightly different work. So the eccentricity is equal to 4/3. So let's first talk about the center. So notice that the Foci is 3, 6, and 11, 6. Let's plot them to see what they represent. So 3, 6, 1, 2, 3, 4, 5, 6. That's one focus. The second one is 11, 6, 4, 5, 6, 7, 8, 9, 10, 11, and the same y coordinate, 6. So there go our Foci, right? So we know, just like with the vertices, the center is going to be right in the middle between the Foci, right? So the midpoint of the Foci in question, right? We can find the midpoint actually, we can find the center visually, but we can't just do that. We have to also use algebra, right? So we know that the midpoint should be what? It should be this x value, whatever that is, 4, 5, 6. So it should be 7, 6. Let's confirm that. So to confirm that, we're going to find the midpoint. So once again, let's do some algebra. So the midpoint formula. So first the x value that we're going to compare, right? We're going to add the x values and divide by 2, right? So we're going to do 3 plus 11 divided by 2, and then the y value divided by 2. The y value for both is going to be the same. All right, so the y value is 6, right? So 6 plus 6 divided by 2. So what does that give us? That gives us 14/2 is 7, and then 12/2 is 6. Bingo. So we confirm that the center is 7, 6. Okay, good. So, and we know that the vertices must be closer, but this is not about really graphing this hyperbola, so I'm not going to graph it, but you know the Foci will be behind the vertices, right? So the vertices will be closer to the center than the Foci are, right? The distance from the center to the vertices will be smaller than the distance between the center and the Foci, right? I'm not going to plot it exactly. I will plot it for you when we find the a value and a values, okay? But so far we found the c values. The c value is responsible for the Foci, the distance from the center to the Foci. So the c value should be equal to 4, right? To confirm that algebraically, c is going to be what? You're going to basically subtract 7, the center x coordinate, from the x coordinate of the right vertex, of the right focus, right? This case is focus. So that's going to be 11, right? This x value of this focus is 11, minus the x value of the center, okay? And you don't divide by 2, right? Because we're not doing any of those, averages, etc., right? So we just want to find the distance, right? 11, the distance from the y-axis to this, minus 7, the distance from the y-axis to the center, gives us the difference, right, which is 4. So we confirm that the c value is 4, just like I suggested using the graph. So the c value is 4, and what is that going to do for us? That's going to help us solve for a when we use the eccentricity, right, because we know that the eccentricity is 4/3. And recall that the eccentricity is defined by c over a, right? So what does that tell you? That tells you that you can substitute e with 4/3, and you can set c over a, and we know that the c value is 4, right? So you can solve for the missing piece here. The missing piece is a, right? So that's that. So a value is what? If you cross multiply, 4a is equal to 12, right? So 4a is equal to 12. That means a is equal to 3. Bingo. All right, so let's circle the information that we know. So a is equal to 3. Okay, and then c is equal to 4, right? C is equal to 4. Let's circle that. We're going to need that to find the b. Okay? So now, how do you find the b? Use this equation. A squared plus b squared is equal to c squared. So b squared is equal to, algebraically, c squared minus a squared. So that means b is equal to the square root of the c squared minus a squared, right? And the b is positive. That's why we don't have plus minus. We just have the plus, right? The b is only positive. So c squared minus a squared. What is c? C is 4. 4 squared is 16. Minus a squared. A is 3, so squaring it is 9. So that means we get radical 7. So the b value is radical 7. And the a value is 3. So we can actually use the a value because the a is the distance from the center to the vertex. And that's 3, right? And as you can see, it makes sense because I said that the vertex is closer to the center than the focus, right? So the graph will look something like this, right? And also the same distance of 3 from the center to the right, right? So this is the second vertex. So the hyperbola will look like this, okay? And the foci are behind the hyperbola curves as they should be, all right? So now we can find the equation. And notice that in this case, it's a different focal axis. The focal axis in this case is parallel to the x-axis, right? And not parallel or on the y-axis, right? So that means it's not going to be y minus k squared. It's going to be x minus h squared. It will have the positive coefficient instead of negative, and it will come first because it's going to be positive, right? So what I'm saying, it's going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So the equation that we need in this case is going to be what? And notice that h and k, as we found before, is not equal to 0, 0 like it was in the first case, right? So h and k are respectively 7 and 6, right? Because the center is not at the origin, the center, right? This is the center point. It's not at the origin like it was here. Here, the center was at the origin. That's why we didn't have to subtract really the h and the k. We just had plain x squared and y squared. Here, we're going to have to actually write the parentheses, believe it or not, and write the square outside, right? So what I'm getting at is that we're going to have x minus, now the h value is 7, square, divided by a squared. A is, where's the a here? 3, so 3 squared is 9, minus y minus k value 6, squared, divided by b squared. B squared was, squaring this is 7. Right, is equal to 1. And now, before I leave, I would like to show you that it's not just about the memory of memorizing which one is the correct order in terms of the focal axis. You can check yourself. In the first case, you can check by plugging in with the known vertices here. You can plug in the 0, you can plug in the 0 for the x into this equation, actually, not this one, but this one. Plug the 0 for the x, you will see that this whole thing is 0, and y squared will be solved for. Y squared would be equal to 144. Square rooting would give you y is equal to plus minus 12, right? So the vertices do play out well. So this is correct. In this case, if you plug in 6 for the y, in both of these vertices, the y value 6, plug in 6 for the y, this whole thing becomes 0. So the negative will not matter because this whole thing will be 0. And this x will be solved for. X minus 7 squared would be equal to 9. And that means x minus 7, if you square root, would be equal to plus minus 3. And then you would have different x values, as you should. You would have respectively the x value of 4 and the x value of 11. Okay? No, not the 11, 10, right? Because this the 11 is the foci, right? So 10. So 4 and 10 would be your vertices, respectively. And again, foci would not work because foci is just a reference, right? That's just part of, this is just a property, right? But that's not on the actual curve itself, right? Foci is not a point on the curve, right? It's something that we orient ourselves on. It's something that relates to, the actual definition of the hyperbola, but it doesn't help us actually solve including that point focus. The focus is not on the hyperbola. The focus is outside of it. But the vertices are, right? The vertices are respectively these two. The y value is 6 for both of these vertices. You will get 0 for this, and then you will solve for x, and your x should be 4 respectively and 10. And as you can see, it will give you the correct vertices as we have already in the graph. So that's just to help you understand how you can check yourself. You can check yourself using the vertices. In this case, you check the vertices that were correct by plugging in 0 for the x, and then your y values were respectively plus minus 12. Okay, so I hope this was fun and helpful. This was very, very detailed. Thanks for watching, and I'll see you in the next video.